Let's see this question. This question is asked in GATE 2013 in the subject analog. Okay, the small signal resistance dVb by dId in kilo ohm offered by n channel MOSFET M as shown in this figure. So this is the figure with M MOSFET. At bias point of Vb equal to 2 volts. They given bias point voltage 2 volts and they given some device data for M. Device transconductance parameter Kn equal to 40 microamps per V square, threshold voltage VTH equal to 1 volt, and we should neglect this body effects and channel length modulation. Okay. Now if you observe this figure, M is the MOSFET. M is the MOSFET and we need to find it out the terminals. So this is the gate terminal. More positive voltage applied towards drain. So this is the more positive voltage and it should be drain. This terminal should be drain and this will be the source. This terminal will be the source. Now we have find out the terminals. Now gate and drain are shorted such that this MOSFET is in saturation region. This MOSFET is in saturation region. So gate and drain are shorted such that this transistor is in saturation region. Thereby we can find the transconductance as the below steps. Okay. So dVb by dId. We need to find out this thing such that we can find transconductance, and by using the transconductance, taking that reciprocal, we can find the small resistance. Okay. Now we can write dVb by dId equal to dVd by dId. Since gate and drain are shorted, we can write gate in place of drain. So dVg by dId. You take dVg to the denominator, that will become 1 by dId by dVg equal to 1 by Gm. Okay. Now this is equal to Gm. So Gm is equal to transconductance. Okay. Now what is the relationship between transconductance and small scale resistance? Small scale resistance Rd equal to 1 by Gm. So first we need to find it out transconductance. Just we have to do reciprocal to get this small scale resistance. For finding transconductance, we need to find out drain current equation in saturation region. So we should find Id, where Id is equal to drain current in saturation region. And equation is given by Id equal to Kn by 2 into Vgs minus Vt whole square. These values are given in this question. Okay, Vth equal to 1 volt and Kn equal to 40 microamp per V square. So substitute these values, but before substituting this, we need to differentiate with respect to Vgs. Okay, now differentiate with respect to Vgs. So dId by dVgs equal to this Kn by 2 will be constant, and here this 2 will come forward into 2. Now Vgs minus Vt. Okay, this 2 will become cancelled. Now Kn into Vgs minus Vt. This we can write Kn into Vg minus Vt. Substitute the values. Kn equal to 40 microamps per V square and Vg is 2 volts bias current. This we can write as Kn into Vb minus Vt, where Vb is the bias current, given as 2 volts minus Vt is 1 volt. Okay, this will be 40, 2 minus 1 is 1, 40 microamps per V. This is dId by dVg. Okay. Now if this is equal to transconductance Gm. Now if you do reciprocal, you will get the small scale resistance. Now we can write small scale resistance Rd equal to 1 by Gm, that is equal to 1 by 40 microamps per V, that is equal to 1 by 40 is you can convert this and you will get 25K. because this is 10 power minus 6, okay, and 40, 1 by 40, if you do all the calculations, you will get 25 kilo ohms. That is small scale resistance. In the options 12.5, 25, yeah, option B 25 kilo ohms is the correct answer.